Okay. Good morning, everyone. Thank you for is here. I'm the first of this morning. I have to broken the ice. I am Paolo Mattavelli from Elecom SPA. I am R&D and go to show you something about a lubricant in this particular moment. We have something we only every of know. We have a problem of energy, and we have to see with good attention for the pollution and the future. And we have an important present for the what can happen in future. Refrigerant lubricants can be the key for this kind of change because the lubricant can change the efficiency and the stability of your system for have a long life inside of your refrigerant system. Every system have two important targets to respect, and we have to speak a lot of what we have to do about the refrigerant gas. But we have to think something about the global environment, about the system too. The four environmental effects, most important is energy consumption, disposal, waste, refrigerant, and lubricant, because the lubricant, same when we cut from the system, have to found a new life, and disposal for the system too, because if the new kind of system have a life more short, this kind of system was reworking and recycling. The refrigerant more speaking in this year for offshore CO2, hydrocarbon like L600 and R219, the HFO and our brands, and the ammonia. This kind of refrigerant have some problem inside of the system, problem of pressure, problem of chemical stability, and this kind of problem can damage and change the correct work of your system and the life of your system. For maintaining the correct efficiencies, we need some additive, but the additive can't be put inside of the refrigerant, but all you need inside your system arrive inside of lubricant. How we select, how produce a new lubricant, we chose the correct lubricant from the family, minerals, semi-synthetic or synthetic, evaluate the impact of environmental impact, analyze the base of the lubricant, and develop the specific lubricant with the correct additive package. The most common family was mineral, semi-synthetic, and synthetic lubricant family. In mineral, most common is naphthenic and paraffinic chemistry. In semi-synthetic, alkyl benzene and PAO. And synthetic, in this moment, was the most important, POE, PAG, and PVE. Synthetic lubricant have an important plus from the difference to the mineral one. They be produced from the natural material, and they are biodegradable. This is an important aspect for environmental. The basic properties you check when you have to select a lubricant was miscibility and solubility of the refrigerant in the lubricant. The viscosity is the most important to select which kind of lubricant inside of this family you have to use. I don't know, most famous 32 or 100 or the 220 when we have a very big system to lubricate. Viscosity index is very important because it's the capacity of the lubricant when the temperature is more higher to maintain capacity to lubricant the system. Pour point is the point where the lubricant stops to work, the solid in the system. Moisture, presence of water inside of the system, because we know the water was a very big problem inside of our system. Total acidity is the presence of acidity, carbon acidity or chlorine or fluorine acidity is children of the refrigerant gas product is very dangerous for the system, and the flash point is temperature which the lubricant can take fire. When we project a new lubricant, we have the step to control and to additive correct the lubricant. The foam level control, quindi anti-foam activation, synthesis, catalysis, residual inside of the lubricant, because if there is something we need to produce the lubricant, stay inside of the lubricant, this product can broken the lubricant to come back to the raw material. And we have to control and eliminate all the catalysis inside of the lubricant, anti-corrosive additivation, antioxidant additivation, and this work for the system, for the lubricant, and for the refrigerant gas. These two kinds of additivation is very, very important and is the key for the future of the lubricant. Anti-moisture additivation, and for Elecom, anti-moisture was a very big, important work because if we are able to remove moisture inside of the system, and don't speak about only the filter. The filter is fundamental in the system, but is static one, is in one position of the system. If you have anti-moisture inside of the lubricant, you have something travel in the system, and it's very crucial, very important. Neutralizing acidity, because acidity is a dangerous enemy of your system, and anti-wear. Of course, when we put lubricant, we put for have a correct lubrication of your system. Every lubricant was a mixing, and in particular, POE is blends. Is when you think a lubricant, you don't have to think only one molecular. Is not like only one specific species, but is everywhere the blend for different material and molecular to arrive to have a correct result inside of the system, for have a correct stabilization, correct corrosion control, and extend the life of all the system. Now we go to see the most important in this moment, our study is for hydrocarbon. Hydrocarbon come back very important in the last year, and we start to study a new type of PAG with a new series of additivation. In this case, we study which kind of capping, because PAG have two cap, or one or two cap and the final of the molecular, and we can select the type of the cap max efficient for the use in our system with this kind of refrigerant, and we can find the best to reduce the energy consumption for the life of the system. The type we call A was in our test the best solution we can find. And between we put anti-foam additive, and we select a new type of anti-foam to put inside of our lubricant. And anti-corrosive was very important. This is a small example of drying filter in one system where there is not protection inside in the lubricant and was completely destroyed from the moisture and acidity present in the system. This is an example of how works the antioxidant additive, and without antioxidant additive, how many is important the correct packages of additive inside of your lubricant. Anti-moisture, we go to capture the moisture inside of the system and protect from reaction, chemistry reaction from the water and the metal of the system, the acidity present in the system, because moisture can produce acidity with the reaction from some material arrive from the refrigerant, from the lubricant, and from the system too. This aspect very important. This is a lot of molecular can stop the water, but the measure produce solid material. And we have find a molecular react with the moisture to produce a molecular is more like a lubricant than not arrive to be solid. Anti-moisture additive, we have found different in the years. Last year, we test a new one, produce a new, more power, and the efficiency in the long time was best with this new molecular than the older we use in precedence. Is very important step to protect our oil and the system too. Second and non-second HFO and HFO blends is very important. Speak about low GWP refrigerant, but if the refrigerant was able to destroy itself outside of the system, sometimes destroy itself inside of the system, we need to long life of the refrigerant have something to reduce the chemical reaction the refrigerant can have. And it's most important when we study a lubricant for a HFO, have a lot of stability, a lot of antioxidant and anti-moisture inside to protect the refrigerant too. The same, the base molecular for this kind of application be different before the other molecular we use normally is a chemistry more similar to the chemistry we use for CO2. Because the chemistry for CO2 was more stability and more stronger. I don't know if it's simply to understand, but it is more resistant to the action to the refrigerant, and we study if best application something more similar than this kind of chemistry to the base. We produce PAG for CO2 and POE for CO2. CO2 is the most peaking in this moment. Refrigerant gas is common, is present simple in the ambient, and for sure is the most attention for our to produce lubricant correct. Have the same history of the other. We need every kind of additive, anti-foam, antioxidant, anti-moisture, and anti-wear, of course. Start to select a correct ester, correct solubility for the CO2, correct additivation for the lubricant, and go to work the system for a very long time to have uh, imagine of what happened inside of the system, have sure to have find a correct application. We can make a study of miscibility of our oil and refrigerant. Is the area the miscible and the area in not miscible. And important know because it's important have in some area miscibility for the refrigerant to have a correct transportation of the lubricant in the system, but not so much miscibility to have not a lot so much lubricant inside of the system. And we can study the with the Daniel plot study correct activity of the lubricant in different temperature and the pressure of the system. And we can understand which kind of viscosity maintain the lubricant. If I have a temperature of work of, I don't know, 70 degree, and in which pressure the system can work. And this is very important to make a project to the new system. The same for the CO2 is important, have anti-foam additive, same kind of the study to prepare the oil, antioxidant additive to maintain stability of the system. And two is for our is one of the big target, anti-moisture for sure. The same for the other lubricant. In every kind of lubricant, for every kind of application in refrigeration, there is not only the lubricant. There is a big part of additive. When some technicians tell me, no, I don't put additive in my system, I put only lubricant, it's not true. The lubricant was full of additive, and must was full, because if you have not additive inside of the system cannot work, or can work, but the life of your system was very, very, very short, and you must put this kind of product inside of your lubricant. Study for the anti-moisture was similar to the other study of the lubricant, and anti-wear too. We have to have the maximum activity of lubrication and the minor request of energy from the system to have correct work of the system. Have to control correctly the viscosity and a correct maintenance of the system in the time. What we have observed in our study, if you found a correct lubricant for your system, for the new refrigerant, we observe an important reduction to energy absorption from a system who consumption 100 kilowatt of energy, we saving the 3 to 5 kilowatt from every step of 100 kilowatt. In the year, we reduce a lot of consumption of the system and reduce a lot of consumption of the metal of the compressor and material. Have 22% of best reduction of this kind of problem. What can we do? And I close my presentation. We have to work to maintain the best efficiency and go to have objective to have the best system ever, not only in refrigerant and mechanical step, but with all attention to the lubricant. It was the center, the core of the compressor. And thank you very much for attention. If you have some question. Yes. Non evacuate. Yeah. Non sto capendo la domanda. Come eh? The additive, no. When you change the oil, you put a new oil with a new additive. Yeah, yeah. The additive don't stay inside of the system. The additive stay in the lubricant. When you have a plane of change of lubricant, you take the whole lubricant with the additive combustion and put a new lubricant with a new additive. And the additive living in the lubricant, you cannot separate the additive and the lubricant. I don't what's your Mr. Yeah. If there's a consumption, is this the question? Yeah. In the oil, the system working. During the work of the system, the percent of additive, especially the antioxidant, will go down because react from the moisture and react from the oxygen. Uh, we speak directly. Okay. Thank you.